Hey guys, this looks like a fun one. It says, what's the area of the semicircle inside this equilateral triangle? So we're given an equilateral triangle, a circle with area 6, and a semicircle right here. And if you want to try this one on your own, pause it right now, because I'm going to solve it in 1, 2, 3. So the 6 is the area of this smaller circle, and the question mark is the area of this semicircle. Let's label the radius of the smaller circle little r, and the radius of the bigger semicircle big R. So 6 would be equal to pi little r squared. And the question mark is going to be equal to pi big R squared divided by 2. These look important. Let's put boxes around them. And our goal is to find this question mark. I think we need to find some relationship with the big R and the little r. And then we should be able to do some substitution. From here, let's drop this perpendicular bisector. And let's make this black and white. First, I want to focus on this orange triangle. Let's zoom in right here. This line bisected an equilateral triangle, so this is normally 60 degrees up here, but this angle will be half of that, or 30 degrees. And then this angle right here is built off of the radius and the tangent line. The radius of any circle will meet its tangent line at 90 degrees. And then all three of these angles add up to 180, so this one would be 60 degrees. Our orange triangle is a 30, 60, 90 triangle. That is a special right triangle. And it's always true that the hypotenuse is twice as long as the shortest side. So this distance right here will be 2 little r. And that correlates to this right up here. This piece is a radius of the small circle. We'll call that little r. And since the whole thing is 2 little r, this remaining piece will also be little r. And then while we're at it, this piece right here is also a radius. Let's call it little r. And we can finish this. This is a radius of the semicircle, so let's call this big R. So the entire height of our equilateral triangle is big R plus 3 little r. Next, let's focus on this larger triangle. And let's zoom in on it. It will also be 30 degrees up here. And for the same reason, this angle will also be 90 degrees. And the remaining angle will be 60. So this is another 30, 60, 90, where the hypotenuse is twice the length of the smaller side. So this distance will be 2 big R. So this whole distance is 2 big R. This is 1 big R, which leaves 1 more big R right here. And this is the relationship we wanted. We have big R is the same thing as 3 little r. This looks important. Let's put an irregular octagon around it. And now we're ready for our original equations. Down here in the place of the big R, we can plug in 3 little r. And this exponent will distribute to both of these to give us 3 squared little r squared. 3 squared is equal to 9, and now let's rearrange this a little. So we have the question mark is equal to 9 pi little r squared over 2. Well, pi little r squared is equal to 6. So in the place of this, we can plug in 6. And then 9 times 6 is 54, and 54 divided by 2 is 27. Let's give it a label of units squared, and that is the answer to our question. The area of this semicircle is 27 units squared. How exciting.